Class 12 Science Unit 13 Amines, and in this video we will discuss about classification of amines and nomenclature of amines. First, what are amines? Derivatives of ammonia obtained by replacement of 1, 2 or all the 3 hydrogen atoms by alkyl and or aryl groups. Okay, in this way we will get the amines. For example, this is CH3NH2. From NH3, one H is replaced by CH3. This is C6H5NH2. One H from NH3 is replaced by C6H5. This is CH3NHCH3. This is a part of ammonia. Two hydrogen atoms are replaced by CH3 and CH3. Now in this case, 3 hydrogen atoms are replaced by 3 methyl groups. Okay. Structure of amines. Like ammonia, nitrogen atom of amines is trivalent and carries an unshared pair of electrons. Nitrogen orbitals in amines are sp3 hybridized and the geometry of amines is pyramidal. You can see this is the structure of trimethylamine. Okay, there is one unshared pair of electron. Due to the presence of unshared pair of electrons, the angle carbon nitrogen E, where E is carbon or hydrogen, is less than normal tetrahedral bond angle, that is from 109.5 degree. For instance, it is 108 degree in case of trimethylamine. This one. Okay. Now, classification of amines. Amines are classified as primary, secondary and tertiary depending upon the number of hydrogen atoms replaced by alkyl or aryl groups in ammonia molecule. Now, be careful. Like classification of haloalkanes and alcohols, primary, secondary and tertiary are classified as to which carbon functional group is attached. Okay, if primary carbon contains the functional group, then that will be primary alcohol or primary halide. But in this case, these are classified depending on the number of hydrogen atoms replaced by alkyl or aryl group in ammonia. Okay, see, this is ammonia. If one hydrogen atom is replaced by alkyl or aryl group, we will get the primary amine. If 2 hydrogen atoms are replaced by the alkyl groups or aryl groups, we will get secondary amine. And if all the 3 hydrogen atoms are replaced by alkyl or aryl groups, we will get tertiary amine. Okay. Amines are said to be simple when all the alkyl or aryl groups are the same and mixed when they are different. Now come to nomenclature of amines. In common system, an aliphatic amine is named by prefixing alkyl group in alphabetical order to amine. That is alkyl amine as one word. For example, this is methyl amine is represented as CH3NH2. In secondary or tertiary amines, when 2 or more groups are the same, the prefix di or tri is used before the name of alkyl group. In IUPAC system, primary amines are named as alkanamines. That is, E of the parent alkane is replaced by amine. Okay, alkanamine. E of alkane is replaced by amine. For example, CH3NH2 is named as methenamine. To name secondary and tertiary amines, we use locant nitrogen to designate smaller substituent attached to a nitrogen atom. Let us see. This is CH3CH2NH2 in common name. This is ethylamine. In IUPAC name, this is ethenamine. This is CH3CH2CH2NH2. This is normal propylamine. And in IUPAC, this is propane 1-amine. Now this CH3, CH, NH2, CH3 in common isopropylamine, and this is propane 2-amine is its IUPAC name. Now in this case, this NH is attached with the two different alkyl groups. This is ethyl and this is methyl. That's why its common name is ethyl methyl amine. But its IUPAC name is, now in this case, this ethyl group is larger. Okay, and this methyl is smaller. That's why this smaller group is written as like this, N methyl. Why this is N? Because this methyl is attached to the nitrogen atom. N-methyl ethanamine. Okay. Now in this case, all three groups are same. That's why this is trimethylamine, or IUPAC name can be written as NN dimethyl methanamine. Clear? Now in this case, this nitrogen contains this C2H5, C2H5, and this is butyl group. Okay. That's why common name is butyl diethylamine. But when we write its IUPAC name, we will consider first carbon atom, this one, that is long chain, okay, parent chain. And these two groups are attached with this nitrogen. That's why we will write N diethyl butane 1-amine. Now come to this one, NH2, CH2, CH, double bond CH2. Now this carbon to which NH2 is attached given the preference. That's why this is 1, 2 and 3. And this group is known as allyl group. That's why in common name this is allyl amine. But in IUPAC name this is prop 2-in-1-amine. Okay. Now in this case, this two NH2 groups are attached to these 6 carbon atoms. That's why this is hexamethylene diamine. Okay, this is common name. And IUPAC name is hexane 1,6-diamine. Okay. In aryl amines, NH2 group is directly attached to the benzene ring. This is simplest C6H5NH2, and this is the simplest aryl amine. In common system, it is known as aniline, and this is also accepted in IUPAC. Okay. While naming aryl amines according to IUPAC system, suffix E of arene is replaced by amine. Thus, in IUPAC system, C6H5NH2 is named as benzenamine. Benzenamine. Okay, benzenamine. This is also known as aniline in IUPAC system as. Now see, this is benzene ring, NH2 is attached aniline. This aniline is also the IUPAC name, or you can also write this is benzenamine. Okay. Now this is NH2 and CH3 at ortho position are attached. That's why in common name this is orthotoluidine. In IUPAC name this is 2-methyl aniline. Now at para position Br is attached. That's why this is para-bromoaniline. And in this IUPAC name, this is 4-bromobenzenamine or 4-bromoaniline. Now this is a mixed amine. Okay, this nitrogen contains 3 groups, 2 CH3 and 1 we can say that is benzene ring. That's why this is N-dimethyl-aniline. Okay, and this is N-dimethyl benzenamine. Benzenamine. Okay. Now see one question. Classify the following amines as primary, secondary, and tertiary. We already discussed how can we classify primary. That is how many hydrogen atoms of ammonia are replaced by the alkyl or aryl group. If 1 hydrogen atom is replaced, primary. If 2 hydrogen atoms are replaced, secondary. If 3 are replaced, tertiary. Now see in this case, only 1 hydrogen atom is replaced. That's why this is primary. Now in this case, this is nitrogen and all 3 hydrogen atoms are replaced. That's why this is tertiary. Now in this case, this NH2. Okay, only 1 hydrogen atom is replaced. That's why this is primary. Now this is NH, 2 hydrogen atom of ammonia are replaced. That's why this is secondary. Okay. Now see one more question. Write structures of different isomeric amines corresponding to the molecule formula C4H11-9. Okay. Now this C4H11, that is 4 carbon atoms are there. attached to this nitrogen in a different way. Now we will get these 8 isomers. Now this one is butane 1 amine, CH3, CH2, CH2, NH2. This is primary. Now in this case, this NH2 is there, that's why this is the primary amine, and this is 2-methyl propane 1 amine. Now in this case, this is at the second carbon atom, NH2 group is attached, but again remember, this is primary. Why this is primary? Because one hydrogen atom of this NH3 is replaced by the alkyl group, and its name is butane 2 amine. Now this one, this NH2 is there, that's why this is a primary, and when you write its name, this is 2-methyl propane 2 amine. Now this is NH, 2 hydrogen atoms are replaced, that's why this is secondary. Okay, and both are the same group, that's why we'll write N-ethyl ethanamine. Now in this case, NH is there, that's why this is secondary. Okay, this is C3H7 and this is CH3. Smaller group is CH3. Smaller group will be written as like this. N-methyl, this is propane 1 amine. Then this is NH. Okay, 2 hydrogen atoms are replaced. That's why this is secondary. Okay, one is CH3 and another one is CH3, CH, CH3. That's why numbering will be done like this. 1, 2 and 3. Okay, and this CH3 will be written as N-methyl, and this one is propane 2 amine. Now in this case, nitrogen, all 3 hydrogen atoms are replaced by the alkyl group. That's why this is a tertiary. And this C2H5, this is larger than this CH3 and CH3. That's why these two CH3 will be written this N and dimethyl ethanamine. Okay, thank you. Subscribe my channel to get the new videos from this chapter.